MS Ramaiah University of Applied Sciences.
Hi students, let us have a discussion on power and phase measurement in three-phase system by 2 wattmeter method. The objectives of this laboratory experiment are to measure power and phase measurement in a three-phase system using 2 wattmeter method. Basically, a wattmeter consists of 2 coils. They are named as current coil and potential coil. 2 wattmeter method is commonly used on three-phase loads or circuits in which current coils are inserted in series and potential coils are connected across all the 3 phases. It can be shown that the sum of the instantaneous powers sensed by 2 wattmeters gives the instantaneous power observed by the 3 loads. In general, the expression for power in a 3-phase AC supply for resistive load is P is equal to V1I1 plus V2I2 plus V3I3. That is, to measure power in a 3-phase circuit, it requires 3 voltmeters and 3 ammeters. So, by the use of 3 voltmeters and 3 ammeters, circuit becomes complex and it increases the cost. These drawbacks can be overcome by the use of 2 wattmeters to measure total power in a 3-phase circuit. Representation of wattmeter. The terminologies used to denote current and pressure coils are M is main, L is load for current coil, C is common, V is voltage for pressure coil. To verify this experiment, we need 4 voltmeters with suitable ranges, 3 ammeters with suitable ranges, 2 UPF wattmeters, 3-phase auto transformer, 3-phase resistive load and connecting wires. While conducting this experiment, the following precautions should be taken. Keep the variac in minimum terminal position, that is 0. Load switch should be in off position. Don't touch the connecting wires when the supply is on. Calculate the power for 3-phase system and show that the algebraic sum of 2 wattmeter readings is equal to the total power dissipated in the 3-phase circuit. Comment on your results. The 2 wattmeter method is used in determining the total power derived from the 3-phase load.
Hi students, let us have a discussion on power and phase measurement in a 3-phase system using 2 wattmeter method. The main objective of this experiment is to measure power and phase in a 3-phase system using 2 wattmeter method. So, before going to do this experiment, let us have a discussion on 3-phase system using 2 wattmeter method. So, in general, we know that the expression for the power in a single phase AC supply is P is equal to VI cos pi, where V is the voltage and I is the current and cos pi is the power factor. So, which is nothing but angle between the voltage and current. So, similarly, in the case of the 3-phase AC supply, the expression for the power P is equal to 3 VI cos pi. That means, when compared to the single phase AC supply, in the case of the 3-phase AC supply, to measure the power, we need 3 voltmeters and 3 ammeters. So, by the use of 3 voltmeters and 3 ammeters in a 3-phase system, the circuit becomes complex and also it increases the cost. So, to overcome this drawback, we are going to measure 3-phase power with the help of only 2 wattmeter methods for a given resistive load. To conduct this experiment, we need one 3-phase auto transformer. It is also called as 3-phase variac. So, mainly it consists of 2 terminals. They are named as input terminals and output terminals, and this is a 3-phase transformer. That's why, so input terminals, it consists of the 3 terminals. They are named as red phase, Y phase, blue phase. Similarly, the output terminal is also consists of the 3 phases. They are named as red phase, Y phase, blue phase. And in this case, the input terminals are connected to the supply and the output terminals you have to connect to the load through meters. This is the 3-phase resistive load. So it consists of the 3 individual loads. So you can use any one load, and this is the first load, and each load it consists of the 3 terminals: R terminal, Y terminal, B terminal. These are the corresponding neutral terminals of the R phase, Y phase, B phase. Similarly, this is the second part of the load, and this is the third part of the load, and each part it consists of the 3 terminals. They are named as R, Y, B, and all the black terminals are indicates the neutral, and these are the corresponding switches for the load. We need 4 voltmeters to measure the voltage. Out of 4 voltmeter, 3 voltmeters should be having the rating of 0 to 300 volts, and 1 voltmeter should be having the rating of 0 to 600 volt. We need 3 ammeters with 0 to 5 amperes rating to measure the current in a 3-phase system. We need 2 wattmeters to measure the power in a 3-phase system. Mainly the wattmeter it consists of the 4 terminals. They are named as M, L, C, V, where M is the main which is connected to the input, and L is the line which is connected to the load, and C is the common terminal. And for the voltmeter you can use either 300 volts or 600 volts, and you should be very careful by using 300 or 600 based on the type of the connection, that is 1 to 2 or 1 to 2. Suppose, so here the connection is given from 1 to 2. So you have to look at the nameplate details of the wattmeter. So if there is a connection from 1 to 2, then this wattmeter is used as the 10 amperes. Suppose if there is a connection from 1 to 1, then the wattmeter is used as the 5 amperes. So according to this wattmeter connection, there is a connection from 1 to 2. That means this wattmeter is used as the 10 amperes. Now if you are using 300 volts terminal, then the multiplication factor should be, so 300 volts terminal, 10 amperes, then the multiplication factor is 2. Suppose if you are going to use 600 volts terminal, then the multiplication factor will be vary. Why? Because for the 600 volts 10 amperes, the multiplication factor should be 4. These are the connecting wires. Let us make the connection of the given circuit. Now first let us make the connection for the R phase. So from the output of the auto transformer, so you have to take the one connecting wire for the R phase to wattmeter M. Now short M and C terminals of the wattmeter. M, where C is the common. Now connect L terminal of the wattmeter to the ammeter. Now ammeter other end to resistive load R phase. These are the connections of the R phase as per the given circuit. Now similarly make the connections for the Y phase. The output of the auto transformer, now you have to connect to the Y phase to wattmeter M. Now again short M and C, similar to the R phase connection. Now L terminal of the wattmeter to the ammeter. And ammeter other terminal to the Y phase. These are the connections of the Y phase. Now make the connections for the B phase. The B phase of the auto transformer to ammeter, now ammeter other terminal to B phase of the 3 phase resistive load. Connect 0 to 600 volts voltmeter across line terminals. Here there are the 3 line terminals. So, they are R, Y, B. You can use any 2 terminals. That means, you can use either R Y or Y B or B R. Now, I am connecting this voltmeter across R and Y. Now, voltmeter is connected across the R and Y terminals. Now, you have to make the connections for the voltage terminals in a wattmeter. So, here there are the two voltage terminals. So, they are named as 300 volt terminal and 600 volt terminal. Here you can use any one terminal to connect the voltage. Now, here I am going to use 300 volt terminal. So, as per the given circuit, first you have to short 300 volts to 300 volts. Now, these two wattmeters are linked with the B phase, so that you have to make the connection from 300 volts to B, the output of the B phase. 3 phase resistive load. Here you can use any one as a resistive load. Now, let us connect first part of the load. Now, here there are the two types of the load, they are named as a star connection and delta connection. Here we are going to make the star connection. Now, this is the R phase, this is the neutral of the R phase. Now, we will use neutral of the R phase. Why? Because in the case of the star connection, all the neutrals are shorted. Now, the neutral of R phase you have to connect to the neutral of Y phase. So, with this neutral of R and Y both are shorted. Now, in similar way you have to short Y and B, the neutral of Y phase and neutral of B phase. So, with this all the neutrals are shorted. So, this is nothing but the star connection resistive load. Now, let us take 3 voltmeters to connect the 3 phase system to measure the voltage. Now, first to take one voltmeter and connect this voltmeter across R phase and neutral of the R phase as per the circuit diagram. So, one end of this voltmeter is connected to the R phase. Now, the other end of this voltmeter it is connected to the neutral of R phase. Now, in similar way connect one voltmeter across Y phase and neutral of Y phase. This is the one end of the voltmeter, it is connected to the Y phase. The other end of the voltmeter it is connected to the neutral of Y phase. Similarly, connect one voltmeter across the B phase under the neutral of B phase. So, one end of this voltmeter it is connected to the B phase, and the other end is connected to the neutral of the B phase. So, these are the connections for the 3 phase power and phase measurement by using 2 wattmeter method. Now, let us start the experiment. First, switch on the 3-phase AC supply. Switch on the load. Now here this auto transformer, it is showing the 0 position. Now apply 400 volts with the help of this 3-phase variac. Increase slowly to apply the 400 volts. Now this voltmeter is taken as a reference to apply 400 volts. Now 400 volts is applied with the help of the auto transformer. So this voltmeter is the reference. So it is showing 400 volts. Now you have to note down the readings of wattmeters, that is W1 and W2, and W1 it is showing 160 watts and W2 it is showing approximately 180 watts. Similarly, the ammeter, here this ammeter it is connected to the R phase, it is showing 1 ampere, and in similar way the ammeter it is connected to the Y phase, it is showing 1 ampere, and this ammeter it is connected to the B phase, it is showing 0.9 amperes. And similar way you have to note down the readings of voltmeter. This voltmeter it is connected to the R phase, it is showing 230 volts, and another voltmeter it is also showing 230 volts, and next the voltmeter it is connected to the B phase, it is also showing 230 volts. With this, experiment is finished. Now you can verify the expression for the power in a 3-phase AC supply using the 2 wattmeter method and using 3 voltmeter and 3 ammeter method. Now bring back the variac position to the 0, that is minimum terminal position, and switch off the load. Now switch off the 3-phase AC supply. Before starting this experiment, make sure that the load should be in the switch off position and the variac should be in the minimum terminal position, that is 0 position, and while doing this experiment you should not touch any connecting wires because we are working with the 3-phase AC supply. It is more dangerous.
At MSR UAS, we spark your imagination unlike any other.